Hello viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, I'm going to talk about Ariane rocket family. So let's dive right into it. Well, basically what we are talking about the workhorse of European civilian expendable launch vehicle. What does that mean? That simply means European Union, when they came to fruition, they were really lagging behind between space capability, aka they did have weapons, like France has some good weapons, European Union I'm saying, basically Germany had good weapons, UK had good weapons, but none of them had good space agency. So flat out they were lagging behind in that department. So they were like, okay, let's build an organization known as ESA, and they're like, okay, let's do things. So they built a satellite and started to lay down the foundation of what we know European Union Space Agency today. So they were like, okay, they went to NASA. It's like, okay, this is the payload, can you launch it? NASA is like, okay, cool, awesome, we're gonna do it, but here's the you cannot use it commercially. And that was such a bitch slap to ISRO, I'm saying, basically European Union. They are like, yeah, this cannot go on, flat out this cannot go on. So and that also you have to understand it, even though they have huge budget, they were nowhere near as European, basically Russia. So fundamentally it was like a kind of we really got to step up our game. So they worked very hard, and all those this was the second iteration, so to say. Fundamentally there was another project which failed, and this time they were like, no, we have to get this done, this has to work, otherwise we will completely, all of those countries, because no country had so much money where they're like, okay, I'm also supporting ESA, and also I'm also doing my own space agency. So fundamentally, even though they have space agency, which is French space agency, Italian space agency, none of them have the budget to be like, okay, European plus Italian, European plus French. So fundamentally they had to have a launch vehicle, so they will no longer be in a position where NASA can bitch slap them or Roscosmonaut can bitch slap them. So they are like, okay, we're gonna do this, and this was launched in 24th December 1979. Now be mindful, it is not very old comparatively speaking, because moon landings have been done at this point in time. So you can find some good footage of this point of recording, and this was made for commercial use, because again they had so many countries, you cannot openly build a ICBM like that. So fundamentally it was a commercial system. And for early rockets, they were utilizing N2O4 and UDMH, basically hypergolic propellant, basically like India's PSLV, because again India's PSLV is directly based on this puppy, as in like engine wise. So this is what we are talking about. Now, what's the logic behind it? Logic is kind of interesting, because if you look at this point in time, Delta and Atlas both were coming into fruition, and they were starting to launch satellites into the orbit. But they were weapons first, not launch vehicles first. This was very first time this amount of people got together and it's like, okay, let's make a launch vehicle first. Not like, okay, we build something and then we attach things to it. No, this was a proper launch vehicle first. So that was the interesting part. Another aspect, which is very unique to this puppy and this puppy alone, is they were focusing on geo orbit. Because back in the day, CubeSats was not a thing. Like if you said CubeSat, like what you're gonna say, like I'm gonna have like a 10 centimeter cube, which is gonna like a Rubik's cube, basically big Rubik's cube, and it's gonna have those things. Yeah, that was unthinkable. But geostationary, that orbit location is so precious, they flat out knew that that is the key. If we cannot get there, we are stuck. So fundamentally everything they built on this puppy was focused on that point, get to geostationary orbit. And for back in the day, they focused 800 kilogram in geostationary orbit. Be mindful, there are many rockets that can send multiple amounts of multiple tons of or stuff into low Earth orbit, but they drop off exponentially the moment you're like, okay, 20 ton to, let's say, low Earth orbit, and it's like not even 15 ton to geostationary, it's like 9 ton to geostationary. So they were focusing solely on get to the geostationary. Low Earth orbit was an added boost. So they were targeting 800 kilograms. Like back in the day, 800 kilogram was thought as like, okay, we can do some actual communication with this puppy. So that was their main focus. Another aspect was, because so many countries were like chipping in their budget and all that jazz, it was like, okay, commercial market must be their focus, because again it's expensive project, and if they can launch multiple companies in Europe wanted to launch their own satellite, and they did not like the idea of going to Russia or to America to launch their stuff. So they were like focusing on that. So commercial market, at the height of this system, they were capturing 50% of global commercial launch. Let that sink in. They were competing against two countries, and they were single-handedly capturing 50% of it. They were damn good, because from day one the focus was solely on commercial market and communication systems. And to achieve this, back in the day, two-stage rockets were not that powerful, and cryogenic, basically non-cryogenic systems are not that efficient. So fundamentally, this using hypergolic fluid, they could not achieve the same thing that they wanted to. So they added a third stage which utilizes liquid hydrogen and liquid oxygen. That's why they can achieve such a high payload capacity into geostation, because once the third stage in the orbit, it is so efficient, it can gain the gain back the speed it needs. And you need speed when you go that up. You don't need oomph, you don't need newtons, mega newtons, giga newtons. You need speed. And that's why Falcon 9 is not chosen for every goddamn mission, simply because it uses kerosene. If you use kerosene, you do get a lot of oomph, you can carry a lot of tonnage, but you do not have the delta v. Basically velocity is not gg. So this puppy was made in such a way that they're like, okay, we're gonna use cheap propellant, no ignition system required. All those things will be awesome, but the moment we go into third stage, we're gonna utilize this liquid hydrogen and liquid oxygen, which is the advanced engine system, and we're gonna get that speed back. So it worked. Fundamentally, amazingly, it worked. Now you have to understand this whole system, they kept upgrading. They made Ariane 1, they made Ariane 2, they made Ariane 3, they made Ariane 4. At 4, they realized the whole structure needed to be redone. Fundamentally, hypergolic propellant were like reaching their final stage. They're like, dude, we cannot get more out of it. And fundamentally, hypergolic propellants are not that easy to utilize. So they're like, no, we need something more fundamental. So fundamental redesign was done with Ariane 5, and that's why the moment you type Ariane, the most likely image you're gonna get is Ariane, because this puppy was redesigned from ground up. It's like, okay, let's compile all our information, what we have learned so far, and let's put into this puppy. And this puppy is kind of inspired by space shuttle, simply because it has a core which utilizes basically hydrogen and oxygen. So it has a lot of efficiency, but again, hydrogen and oxygen does not have the oomph necessary to actually launch. So they use solid boosters on the side. Benefit of this, it has only 3 engines and YOLO amount of capacity. Basically, the amount of tonnage it can send into geostationary, it's mind-bogglingly awesome. For example, it can take the satellites that generally requires one whole rocket to be booked for it. It's like let's say a TV service provider is like, okay, I want to launch this satellite. They're like, okay, this satellite is, let's say, 1500 kilograms. It's like every other manufacturer would be like, yeah, that's you have to book the whole rocket for this. And this company was like, yeah, wait, we'll reduce the price, we'll add one more satellite to this. That was the whole point. Inherently, the core was so GG, and because they had the solid booster to get off the ground, and once they had the speed, they will jettison the side boosters, and core will rocket them to very high speed. They reached a point where they can launch 2 very heavy satellites into geostationary orbit, which was unheard of at that point in time. Like even today, like the amount of satellite tonnage it can send into geostationary is mind-bogglingly awesome. So that's why this has stayed competitive in market, and surprisingly large amount of satellites that you use for communication were launched by this. And again, this also became the backbone of ISS resupply missions for European side, and basically the navigation system of European Union. Galileo was also launched utilizing this. Actually, it utilized everything they had. So this was like, no brainer, so to say. So cryogenic, they learned a lot that like you need to have cryogenic if you really want to compete in the ever-changing market. So Ariane 5 became the, like right now, if you want something like that is solid, robust, and carry some serious amount of tonnage to space, Ariane 5 is the option. Now that itself does not mean anything. That simply means, okay, there were some people, they got together, they made a rocket. Why it's such an important thing? The reason is legacy. At this point in time, when I'm making this video, they have bare minimum 235 successful launches as a whole family. That's damn good. That's not like good, that's like whoa. So that's very good. So what does that mean? That simply means they have very high degree of confidence. Basically, other people can trust them. So for example, let's say SpaceX comes as a company. It's like, okay, we are SpaceX, we're gonna launch your rocket, launch your satellite, so to say. Everybody's like, awesome. How much you gonna charge? Oh, you're gonna be less than everybody else. Okay, awesome. How much is the insurance cost? We're like, yeah, it's 10 times higher. Why? Simply because nobody knew what SpaceX can do. SpaceX did not have a history, and insurance rate is directly proportional to your history. So if you have like 500 successful launch, they're like, yeah, insurance will put a very little amount, because even if something goes wrong, they will have like piled up money from like last successful 500 launches. So fundamentally, success has to be earned. It cannot be just like, I made an amazing rocket, nobody's gonna give it a. It's like, unless you prove it 10 times or 20 times, nobody's gonna buy that. And that was an issue with SpaceX in the early on. Like, heck, they had to actually legally fight in order to reach a point where they're like, okay, can you please allow us to at least bid for military contracts? So this puppet has no such an issue, because the history, because of the amount of successful launches, it's like very high degree of confidence. What does that mean? That simply means Ariane 4 and Ariane 5, each of them have almost 100 successful launches on their own. There are very few rocket families that have 100 launches, let alone having 100 each and be like, yeah, we have a successful 200 plus missions. So that's mind-bogglingly awesome. That is why, like, at the peak of its capacity, it was capturing 50% of commercial market. So that was like mind-bogglingly good because of this puppy, and that's why it has been selected for $10 billion space telescope if it ever gets built. So fundamentally, that's the sole reason. If you have one of a kind material where you cannot take risk, the only option where you can go, like, yeah, there is a very good chance this puppy will actually launch successfully, is this. That's the whole why. That's the whole importance why Aryan is so important, because of the legacy. Everything else till this point is like, oh, it's a company. It's a people who build a rocket. Nothing interesting. But like, the whoa, you have been successful 200 times. Yeah, that's at that point you're like, whoa, that's the important thing. That's why they can be trusted with James Webb Telescope. $10 billion. I hope it works out. So what we can expect in the future? Well, reality is, I have provided a video down below. It is interview of Elon Musk in 2012, and flat out he was like, yeah, Ariane 5 will not work out for cost reason, and that came true. Again, came a bit later, but it did came true, because again, Elon Musk was original planning of launching human crew to ISS was much delayed. So again, acceptable. Like, SpaceX is a new company, and not to mention they do not have military budget. Understandable, but again, it did happen. So what he was claiming was like, dude, your operational budget is too goddamn high. You're requiring too much money to do too little of thing. So you had to go to Ariane 6, and that was in 2012. That came true. And right now, European Union is pouring every single amount of money to make Ariane 6. The reason for that is there are certain limitations with Ariane 5. It's a good rocket, it's an awesome rocket, but it was like it is lacking in certain department. So they're like, Ariane 6 is built, and Ariane 6 core, the sole reason why everybody is pouring money into this is European Union should not need to go to anyone else. All the government or agencies from basically France to Italy to Germany to whatever else have you, all of them can rely that no, European Union Space Agency got itself, like we got this, we can take care of this. So fundamentally, self-reliance is necessary at this point in time. So when you see the meeting, I have provided that also down below. Everything is focusing on that point. Like, we should not go to someone else. We should not go to Falcon Heavy. We should not go to Delta V. We should not be like that. Like, flat out, no. We're gonna do the launch ourselves. Everything ourselves. That's the self-reliance part. So fundamentally, they are in a good position where they do not have to worry about, hey, what will happen if we run out of commercial clients, because they are losing that, and they are losing it fast. And you can check out that in the fundamental the guy who's doing the interview is like, yeah, commercial market has become much more difficult, because while it is true Falcon Heavy is not used that much, and Falcon 9, while it does have record, it does not have this much record. So Falcon 9 is in a position where it's slowly taking away, and there is nothing, flat out nothing in the market at this point in time that can compete with Falcon 9 Block 5. Nothing. Not in cost, not in performance, nothing. It's just like, no, you have to double or triple spend it. So commercial market is slowly drifting away. So fundamentally, they are like, no, this puppy should allow a break, at least, like, slowly leading, rather than like, open cycle system. So they really want to do this, and they're gonna make two variants where they're gonna have 2 side boosters or 4 side boosters, and 4 side boosters should allow them to milk their main advantage to have 2 geostationary satellite again. So this is their main aim. They want to reduce the cost, they want to give self-reliance, and they hopefully want to stay competitive. And they do have one advantage: because of their legacy, people can trust them. They're like, okay, we can trust large expensive equipment with you for the first go, which will be, let's say, for example, Jeff Bezos actually figures out how to make a rocket and actually makes a rocket, not just like CGI image. No, this is actual rocket, and that will be the same problem with him also. Like, people will not be like, yeah, I'll take my $10 billion satellite. Nobody's gonna do that. So that is a fundamental roadblock, that is like chicken and egg situation. So this company has that advantage. It's like, there is no chicken and egg. People will trust them. It's like, regardless, you have done good enough that at this point in time, if something bad happens, it's like once in a million kind of chance. It won't be like incompetence, it won't be risky. So future is solid with them, but their commercial market is like doubtful at this point in time. There is no chance that they will go back to their legacy where they're 50% of commercial market. That's not gonna happen anymore. But let's see how they unfold. So this was my presentation of Ariane's rocket family. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.